All right, so what do we got here? I'm going to go for the exact answer part here. So that means I need to do some algebra on this, because just looking at a graph or just looking at a sequence of values approaching 36 might not give me an exact answer. And a trick I used in the past is squares and square roots are related. So x and the square root of x are related, kind of like x squared and x are related. So I'm just going to do a little substitution. I'm going to let u equal the square root of x. And then to get rid of the square root, I'm going to square both sides. So then if I square both sides, I get u squared equals x. And so I'm just going to replace the square root of x with a u, and I'm going to replace the x with a u squared. So I can rewrite my limit, or actually I'm just going to rewrite not the whole limit, but the just that expression as u minus 6 over u squared minus 36, right? So square root of x, I'm replacing that with u. And x here, I'm replacing that with u squared. And I know the denominator factors as u minus 6 times u plus 6. And I'll show another way to do this just for fun. And then I can see this factor of u minus 6 in the numerator cancels with the u minus 6 in the denominator. And remember, canceling means a number divided by itself is 1. So this must be 1 over u plus 6. And I know u is really the square root of x. So this is really 1 over the square root of x plus 6. So this limit right here is equal to the limit as x approaches 36 of 1 over square root of x plus 6. And if I cheat and plug in, I get 1 over square root of 36 plus 6, which is 6 plus 6, or 1/12. So I should see this limit goes to 1/12. I should confirm that on a calculator. But first, another trick. So another trick I showed for when you have a square root plus or minus something is to use the conjugate. So if I take the square root of x minus 6, its conjugate is the square root of x plus 6. So what I could do on my fraction here is I could multiply top and bottom by the conjugate of the numerator. So in the bottom, it's supposed to be a parenthesis. I multiply by the square root of x plus 6. Now I'm going to leave the denominator in factored form, but I'm going to distribute the numerator. And here I have this sum times the difference. And so the middle terms are going to cancel in the numerator. That's going to give me the square root of x times the square root of x, which is x, minus 6 times 6, which is 36. And on the bottom, notice I have a factor of x minus 36. And I also have a factor of the square root of x plus 6. And this factor in the top cancels with that factor in the bottom, leaving me just 1 over the square root of x plus 6. So there's two different algebraic techniques that work here, substitution or a conjugate. And both lead me to this limit of 1/12. Now, maybe this is a test question. I want to be super sure this is correct, so then I whip out my calculator. So on my calculator, let's get rid of that and that. I'm just going to enter that as a function. So f of x equals fraction x minus 36, or let's see, did I get that right? Square root of x minus 6 in the numerator. Let's see, where's the square root button down here? So square root of x, let's get rid of that extra x, make that a 6, and then the x minus 36 goes in the bottom. And what I should find is that if I plug in 36, I get undefined because I get 0 over 0. Now we know 0 over 0 is not really undefined, it's indeterminate, it may have a value. And we determined that right there, and let's look over here. So we'll just change the scale with the monkey wrench here. Let's go out to x equals 50-ish, put 36 kind of in the middle. And we can zoom in on the y-axis. Maybe 0 to, where's 0.1 put us? That's not too bad, maybe 0.2. All right, there we go. And I want to know what's going on when x equals 36 And it looks like the function passes through that line, but here I can see there's something's going wrong at 36. There's a hole there, but I think that hole can be filled with the point 36, 1/12. Okay, so the limit tells me a couple things. First, I know that this function here has a hole at x equals 36. There is no y value there. However, the limit exists because as we approach from the left or the right, the y values seem to be behaving the same way, right? So if I check out what is f of, what's right below 36, 35.9999, I get 0.08333-ish. And if I go to the other side, f of 36.00001, I get 0.8333, a bunch of 0.333s after that. And if I compare those decimals to 1/12, I can see, yeah, look at the y values on each side of x equals 36 are approaching 1/12. So although this function has a hole there, I can patch that hole because I know the limit. And I know the limit in two different ways now. I can see it numerically, I can see it graphically, and I've confirmed that algebraically. So just to make a little note here, checked on graph. Boom, done. All right. So that was exciting, wasn't it? It was kind of cute.